just briefly back up on, we've had a couple questions during the break, so I can, on the application form and application, those are examples and guidelines. Those are not specific cast in concrete. And for example, in terms of the Citizen Advisory Committee, we've had questions not only today but in the past, and it's your community. Some people want like PSO or their utility company, gas and electric, and then some other citizens. We've had one community that said, well, we have trouble with getting good quality turnout people on a regular basis. If we have like a bond issue or something and we want to pull a committee together, they're real good help for 3 months and then you can't get them back until there's another major issue. Well, if that's the case in your type of community, it may be better for you to have, instead of 5 citizen advisory, maybe there's 3. Maybe in another community there's 7. The 5's not cast. I'm just looking for uneven numbers in terms of voting or, you know, agreeing on something. You don't have 2 to 2 against each other. In one city they said, well, is it all right if we have the city council? I said, fine. We're looking for, in your community, we're looking for 3 people to 5 people to 7 people. The fewer I found, the fewer the better. The more you get, it's like Congress can't agree on anything. But we're looking for people who really care about the community, want to take an active role in the community, and can impact. If they're private citizens, or, you know, just people, someone who carries credibility within the community, someone who people recognize, and you know, because what this can be beneficial for as a Citizens Advisory Committee, not only this program, but the same people, just like the Capital Improvements Committee, can help you when it comes time to buy things and spend money in certain ways if it's a political nature or whatever. So it can be beneficial. There's nothing cast in concrete. We're just trying to, the bottom line of the Citizen Advisory Committee is to apply pressure to the city government to keep the program going. That's what it's all for. That's their purpose, is to educate the public about why you're wanting to do what you're doing, and to keep applying the pressure that says, hey, they are doing it. No, that's not true. This is where they spent the money. This is the intent of what they're trying to do, and here's what we're doing. Here's where we're going. And last year we saved X amount. And when you have questions, well, why are they wanting to buy a gas absorption heat tanker? I don't understand why you just don't go down here to PSO and buy one of them. You know, buy what you're used to buying. Why are you spending more money for this? You know, that's where they come as a buffer to the city government. They can explain, no. Here's what we're doing. Here's why we're doing. Here's where we're going. Here's the reasons behind it. And so, and then plus they help, you know, you have quarterly reports to them, and they can help you. I mean, it can be the negative to the city council being your Citizens Advisory Committee is you can have an administrative, if you have good people, they can review all the data with your LEO, whoever's your LEO, and they prepare the reports, and they can go through all the rhetoric and put it down into an essence to present to city council, instead of going through all the lengthy process. No, here's what we've done, here's what we've implemented, here's where we're going, here's what we've saved. So it's a useful tool, but we find it to be very helpful. But there is flexibility. Same with the LEO. Yes, that was another thing. Go ahead.
Okay. We're afraid that we're going to have to rush through the material and all. So as we were talking just a little bit a while ago, we felt like it might be beneficial if we go ahead and take a little bit of time to introduce each other and tell a little bit what we do. I told you about myself, but I don't know if Mike and Charlie and Ed have told you a little bit about their background. And we know about most of the individuals in this room, but you all don't know about each other, so that might be beneficial. You want to go ahead and start, Mike?
Okay. Mike Jones, I'm a registered or licensed architect in the city of Tulsa. My background experience is I was with the oldest architectural firm in Tulsa for about 10 years. Prior to that, I was with firms in Oklahoma City during college and things. Got about 17 years of experience as a licensed architect. My projects primarily have been industrial based. Memorex Telex, or Telex at that time, was a major corporate client I had from 1982 through 87. Still do work with them, but they're not doing that much. We've done everything from, I have cogeneration facilities for computer. They have a centralized computerized system, and if it goes down, they're shut down globally. And And so we've done cogeneration to isolate it from PSO or utility company spike, shutdowns, business interruption. They lose $25,000 per minute business interruption. If you call Delta Airlines or Eastern used to, and different companies like that to schedule, they were the one computer system that operated those for the airlines, certain airlines under contract. So I've done everything from that to industrial manufacturing facilities for electronics, office. I've told you one program for the passive solar. So it's quite a spectrum over the years of different range and variety. I've got my own practice now. This is my third year, going into my third year of private practice, my own firm. So during the economy of where we are right now, it's tough out there, and it's tough for all the firms. And so I'm getting a good education once again on what it's like to survive in Oklahoma in the 90s. But that's a little bit about myself.
Yes, Ed Stone. I'm a licensed engineer. Mechanical engineer is my background. Mike and Mike referred to earlier, us being at the same firm together. I stayed at that firm 3.5 years through the period until 1982 when I started my own firm, and I've been in private practice since 1982. And I'm currently a senior facility engineer at Rockwell International in Tulsa. Again, relating to the economy, I joined them as a reflection of how the economy is on consulting engineers right now. But this program Mike and I started, and Charlie started with OSU and Anita in 1989. I'm a graduate of University of Oklahoma in mechanical engineering, and I've been working with these energy programs, beginning with the Corporation Commission in Oklahoma in 1985, and every year since then.
Might tell a little bit, maybe what your role on the project is.
Oh, true.
Yes, well, my role is more of the number cruncher, technical analyst, kind of keeping us on the straight and narrow as far as turning the numbers go. I have a background in equipment and air conditioning systems. I look at it from the equipment side of the house as opposed to how Charlie and Mike would look at it.
Right. My main emphasis is in more the educational road, pulling the literature together, also helping with the audit process, answering questions, and looking at it from an architectural standpoint on how you use the facilities, how the facility is built, the maintenance on the facility, the lack of maintenance, the lack of quality of design, that, you know, the way technology has exceeded, you know, when facilities were built, the way they've changed, and how that plays a role in the program. And I might say I'm a graduate of Oklahoma State University versus OU. By the way, you know how Cowboys count? 01, 02, 03, 04, 05. Some of the new jokes going around. I don't like them, but that's the way it goes. Charlie, Mike.
My name is Charles Cruz. I'm a registered professional engineer in the state of Oklahoma and Missouri. My participation in this program, and what I try to do is to get Mike and Ed to work is to do as much of the work as possible. I am semi-retired, retired from Rockwell International, as their corporate manager of energy conservation in Pittsburgh, Pennsylvania. I came back to Oklahoma and sat around for a few months and formed my own company. And I've been doing consulting work just on my own since 1984. I was graduated from Rose Polytechnic Institute in Fairhope, Indiana. And I won't tell you when, but Harry Truman was president. And so it's been a long time ago. And it's a challenge to me to keep up with these two guys because like I say, I sometimes get less than enthusiastic about working every day.
Start right here.
I'm the city clerk at Nowata. I work with the budget and all the expenditures as far as all the utilities and, you know, all that. I work with the water department, which we have there in the city itself. And basically that.
So you're gonna be the local energy officer then?
An important person, because if you make her mad, you don't get paid.
You know, one thing we might also address is if there's a particular concern that your city has or a reason for wanting to participate in this program or something that you're addressing that's really upfront in your mind right now, you might voice that as well.
My name is Buster Wilcox with the City of Seminole. I'm the Community Services Director there, which is basically a catch-all department. I have the inspections, permits, we have the landfill, 2 community centers, or senior citizen centers, parks and recreations, and those type of things. The main reason why we came was to find out how we can better use the energy in our existing facilities. I also have athletic facilities that I'm interested in, and those type of concerns.
Yes, sir.
I'm George Glenn, City of Seminole. I do all the maintenance, repair, remodeling, take care of the air conditioning, heating, plumbing, electrical. And I'm 37th year with them, which
It's a long time. So obviously, you are doing your job. You wouldn't be there that long.
I'm Kathleen Ryan. I'm a librarian at the City of Seminole. I assume that they want me to catalog all this information. OU degree should help. I'll just catalog it, put Dewey numbers on it, file it away. George can tell the history of every building in that city, which is, I think, going to be a real
Very
asset
important.
because I've heard stories about the many remodelings of City Hall and so forth. So, well, work on
It's important.
Roger Frank, co-leader, I'm the building inspector and work in zoning, issue permits, and that's basically it.
And I'm Joyce Terry, I'm the city clerk in the city of Toledo. I also see all of the utility bills that come in to the city, and it's our hope that this program will help us be able to save a little bit of money on our utility bills so that we might be able to put that money to a little bit better use for the citizens of Toledo. It's actually their money that we're spending, so we think maybe we can apply this money somewhere else that we really need it. And I'm sure that we have some ways we can cut down on this, some way to help us.
I'm George Cecil, the City of Lindsay, Cost Control Officer, the hazardous communications, chemicals, a lot of various different federal laws and regulations. I'm here because I think the city manager didn't have time to do it, so here I am.
I'm Pete Peterson from Durant. I am the Public Works Director there, and we've got approximately $10 million worth of new projects going, got a new reservoir, airport project going, got 100 blocks of overlayment for streets. And we are very concerned with our energy. We have began a program already to educate our employees about turning off lights, all the supervisors. And the other night I come by City Hall, and I tell you, here every light on was in City Hall. Well, I stopped and I'm like, yeah. These are the attitudes that we gotta get going again, because I'd like to know what percentage, if we just change our way of thinking to see what percentage we can save on energy, to be astronomical.
It'll amaze you.
Thank you.
I'm Gary Tucker with the City of El Reno. This is the fire chief there, also fire inspector, and various other jobs. I was chosen to lead on as assistant.
I'm Don Glass. I'm the zoning administrator in El Reno. I'm also the draftsman. I've tried to keep the record drawings since I've been there, just to update the record drawings and have some access to what drawings they have. So I've chosen to do this because of the basic, some of the works, but I've been in looking for the drawings that we had for the buildings you're requiring every one, and I had to write a letter to the architect in Tulsa set of our municipal building drawings, because I had 37 sheets and I had 14 of them. So our records are not too good shape, and I've got a job ahead of me just trying to pacify the qualifications just to get the building started. We're here to try to save a buck. We learn how.
Yes,
I'm
sir.
Dick Carter, I'm head of the water system for Burlesville, and we're in the process of heading toward an upgrade of our water treatment plant. Our basic facility is a 1948 building that's extremely unenergy efficient. There's holes in walls, all sorts of things that need major work, the boiler is in terrible shape. City Hall's the next church, you go down to the utility county department, everybody down there has to have an individual heater because the heating system's ineffective. Overall, we just need more efficiency in things.
I'm Harvey Massey. I've spent about 20 years in various levels of local government. Recently hired, but been needed. This is my third day on the payroll. One day was a holiday. It was like the first 3 days going to meetings I've been in Tulsa and here. But I'm sure their goals are very similar to everyone else in this room. It's a savings to their citizens, not just a savings, but savings to their citizens.
I might make a comment on Benita. I'm glad to see that when we met with them, they were going to have a consultant fill the role for a while.
Tony Dark, I think, was
Right.
You may want to change it on that application.
Good. And I'm glad to see, and not anything against the consultant, it's the firm I'm familiar with and everything, but I'm glad to see that they made a commitment to a person, not only just for this job, but for the other responsibilities you have, because the last thing we really want is work with another consultant. I mean, not from our standpoint, we'll work with anyone, it's just that from a city standpoint, when he walks, you lose all that knowledge, you lose everything that they put in that project. You only have it as long as that consultant and you're willing to pay. You know, so I'm glad to see that, that they've hired someone that's doing this too. That's good for them.
I'm Lonnie Birdsong with the city of Wetumpka, and I've been with the water and sewer maintenance for about 7 years. I'm also the sewer plant superintendent, and I'll be the legal officer there at the city of Wetumpka. We're basically just got a lot of old buildings we need to conserve in, so we're here to learn all we can.
You said Birdsong?
Yes.
Did you have a brother by the name of Walt? Or a cousin?
No, got a lot of
Different
folks here.
Okay. Oh, we've got an officer where I live. It's Walt Birdsong, a real fine person. And it's not a common name, so I thought maybe
Yeah.
we might know each other.
I want to, just a little bit of housekeeping. To clarify, we're going to provide luncheon today, which is optional. You can choose to go check into your hotel or go to luncheon, whatever. The luncheon is going to be in the student union. If you have the maps that we're directing you here, it's also on there. We will probably walk over there. Some of you might want to drive because it is on the opposite end of the campus. There's a student union, it's in the Harlan room. And that'll be at 12 o'clock, so we're going to try to get up there by Spencerville. So if some of you would like to walk over with us, or if you want to follow the map and drive, it's over towards the dormitories. So it's the new student union. So we will provide lunch today and tomorrow. We will be on your own for the evening.
And I might say one thing about myself, that throughout the program, I'll make pretty blunt comments. Please don't take them as personal or reflecting on the character of your municipality or anything. Like, for example, when I say it's obvious no one's doing maintenance, what I mean is, when you go to facilities, every city that we've looked at is a direct reflection upon what you're facing in terms of the economy in Oklahoma, what you're facing in terms of budget crunches, what you're facing in terms of lack of people because you're short, because you got to keep the money down, and you're putting out fires. I mean, I know that. I used to be a city councilman, and I understand the pressures to bear and what you're facing and all that. But I say things as a matter of fact, and they're pretty blunt, but they're not really meant. That's just my personality. They're not really, so excuse me, they're not really meant as though they're directed. Charlie and Ed get on to me and Nita all the time because it's a fact. When you go look at the facilities, it's hard to do the maintenance. There's never enough money. There's never enough people, and they're always catch-up football. And the moment you get ready to schedule to work on something, you got to go over here and solve the city manager because he's quit. As soon as you get that done, you can get ready to start back on this job, then you have a water leak. So, it's just, we come in there and we just make blunt comments on assessments of what we see. And I picked on Enid, Ada, and Okmulgee incredibly, and I have a good rapport with them, and they call me up, and the city manager now says, my name to you is now Mr. So-and-so, you know, so we kid each other quite a bit, but getting back to the program, on page 4, again, this is just keeping in line with the items that overall direction of the project. Curiously enough, lighting's the first thing that they have there to take a closer look at your building. That's as Charlie will get into. You'll be amazed. I won't even steal that thunder, but you'll be amazed on lighting. It's just incredible. Hot water, the way in which you operate it. I will touch on that and the fact that, and Ed will in more detail, or Charlie, I forget who's speaking on that later. We go off in the building and leave the hot water tanks running all weekend. No one's there. And they're cycling. Simple timer. You know, you have holidays, and they're set there in cycles. They burn electricity, and they heat or gas, and no one's using them. Same's true with other machines and equipment. That's the next item on the list. The way you operate vending machines, simple vending machines will amaze you. And they sit there, and after you're gone for the weekend, they sit there and pull juice and they cycle. You know, you put them on a timer. There's several things they can do, and the payback's there. Motors and equipment, compressors. How many shops in every municipality has a compressor sitting there, plugged in, all through the night, not just weekends, but every night. Sitting there cycling on, cycling off, keeping the gas, keeping the compressed air pumped up. And no one's needing it. You know, you need it for 8 hours out of 24. You know? I mean, there's all types of things like that to look at. The envelope, which I'll touch on and be very critical on in many ways. HVAC, Ed will deal with the way you, not just the equipment, the conditioning equipment, the maintenance equipment, also the way in which you operate the equipment, the way you can peak shave and the way you can set your thermostat settings, the way you can turn them off an hour before closing. There's ways you can do things with timers, pros and cons. And then if you don't understand, call an expert, or I prefer to say a consultant. I don't consider anyone experts. Item 5, it's easy to save energy dollars. And I mean, in basic terms, it's real simple and it's true. I mean, there's 10 items listed there, and these are as basic as you can get. But as one gentleman said, and it's amazing, and as a councilman, I was outraged. I mean, why? You got the planning commission one night, you got court another night, you got a capital improvements committee the next night, you got a council meeting the other night. I mean, let's see how many nights we can drag this thing out to keep loading the structure and have to run all the equipment. I mean, let's find ways to waste electricity. It's like, that's our goal in life. It's amazing how many ways we just take for granted to consume electricity without even giving it a thought. And turn off the lights. Remove unneeded light bulbs. Replace existing light bulbs with lower wattage, more efficient ones. Lower heating settings. Raise your air conditioning settings. And we're not talking about uncomfortable levels, because the last thing you want is you got to have a comfortable workforce. People aren't going to do your job, and you don't want to sacrifice that because you're robbing Peter to pay Paul, as the saying goes. You're spending a nickel, you know, cost you a dime, you're saving a nickel. All those cliches. You know, there's common sense, but there are things you can do. And Helmerich and Payne, a company in Tulsa, has done some things. And I don't know if they've done it for energy, but they have a program like on Fridays. It's in the summertime they'll have a shorts day. I mean, no shorts, nothing like that. They can't have that, but they'll have, you know, like a shorts day or a short sleeve, you know, an informal day, a jean day. And it's to set the tone for the summer, usually in the spring or the summer when the air conditioning season starts to relax. And they change their hours of their operation. They go to 4.5-day work weeks in the summer. Employees love it. Now from a municipality, you've got to deal with those issues of everybody come in on Friday, I want to pay my bills, and all these complaints. You know, it's other consideration than a private company. You can do what you want. If you don't like it, go buy it somewhere else. But with a municipality, it's a little bit different. But there's no reason why I can't work 4.5-day work week through the summers. You know, you got to be creative and look at it, think it through. But you can shave temperatures 1 to 2 degrees amazingly. And if people don't wear stuffy ties and long sleeve shirts and to look professional, then you know you can, if you wear short sleeve, knit shirt, or etc. It's amazing the difference it can save. But you have to make those judgment calls. Turning off your heating, air conditioning, and unoccupied hours on your thermostats and on your timers. There's things you can do that there's no need to have the equipment. How many people at the end of the day go set the T-stats for a night setting? No one. Unless it's pre-done, no one. City of Enid, I pick on them the most because they're the biggest. You have a city that's only 3,000 people, and it'll have energy waste proportionally the same, but if you put on grand scale the size of Enid or the grand scale size of Tulsa, I mean, just, you rub your face all through it. I mean, it's just everywhere. It's so gross because it's every street corner. Enid, on their central fire station, they had their thermostat setting on 85 for the unit heaters, and they had the doors open and they're washing the fire trucks. They're set on 85 and those blowers are just going. It's done every day in every municipality. We had the same thing in Okmulgee, but it just wasn't as blatant because the city of Enid is like 35,000 square feet, and there's 15 truck doors on the central fire station, and they have 6 of the remote fire stations. You know, so you're just going, Steve, and Chris, Okmulgee has 2. You know, so the degree of severity, you're just going, golly, and you're just putting numbers to it thinking, look at the waste. The fireman doesn't care. Picking on firemen here. I mean, they're doing their job. It's not their responsibility to worry about that. I mean, they got other important issues. They're not, you know, I don't blame them. I mean, I'm worried about saving lives. I'm worried about this. I'm not worried about, okay, it costs $5 more a month. Well, it costs a lot more than that, but they don't think it that way. It's not where they're concerned with it. Anyway, the 10 items you can go through, they're very basic, and that's a lot of the low cost, no cost. There's a lot more than just that, but those are quick 10 fast ones that will be amazed what you can do with that. And excellent investment possibilities you'll just uncover when we go through this, through the whole program. Do you rent your space? We found situations where Ada, leased out a community service center, was leased out to a different Arts and Heritage Foundation, separate private funded company. But the city of Ada is paying the utility bills on it. I mean, when you go rent a space from any landlord in America today with the energy, you pay your utility bills. I mean, they figured that out in 1974. City of Ada goes, are you sure we're paying the bills on that? It's right here, it's got your account. I gotta go to the county department, I don't understand. Why are we paying the bills on this? Don't look at me, I don't have any idea. They were not even aware they're paying the utility bills. So you need to look at if you're renting spaces out or if you're renting spaces. You know, it even impacts that. When to use this book, there's some things there on when to use it. I'm not gonna go through those because we're pretty well, you know when to use it. You're gonna uncover that for this program. Page 6. All I might add, if this is very informal. If you have any questions, raise hand or just speak up. You don't have to raise your hand. Just speak up, ask a question, make a comment, or say, you know, I don't understand that, or I don't agree with that. You're not going to offend me or hurt my feelings. I got pretty thick skin. On page 6, your guide to investing in energy conservation, expert analysis and adjustment. You know, you analyze those parts. That's what we're going through. That's where we come involved, and the consultants on this to help look at every aspect of that. And then we look at the next thing, your capital investment on new equipment, you know, your payback, your cost of the burner versus the savings, or the cost of whatever the implementation is divided by the savings. We'll get a little bit more complex than that. You got a simple payback or more complex than that. This on page 6 and 7 just gives you an example of what to go through, and it's real basic, and it's a good example. They've got one here on changing fuels. What about changing fuels? Well, that's a consideration, and that can be everything from fleet vehicles. The city of Enid is converting part of their vehicle fleet to compressed natural gas. For schools and for municipalities, for certain fleet vehicles, it makes sense. I've not bought off
There's a
one.
mandate on them school buses, isn't there?
I'm not sure about that. I don't know.
I thought there was. Maybe I could be wrong.
I don't think so. Anyways, we're not aware of it yet. But it can be everything from changing vehicles to from propane to natural gas, from electricity to natural gas, from gas to electricity.
They changed their to compressed natural gas on their emergency vehicles too, or is that just?
No, that was on their strictly on their, I think their EPTA, Enid Public Transportation Authority. I think they changed it on their The first phase was their taxi and transportation handicap, and the second phase, I believe, is for their service and maintenance trucks. And then third phase, I don't believe for police and fire and that they're going to do that until, there's some things that we'll show you in here later on the alternative fuels that there's some pros and cons. And right now the cons I can't recommend for emergency vehicles. There's a loss of power consideration. I mean, it's strictly economy and environmental. It's clean burning and that, but there are some negatives with it, with the combustion engine, and their technology is catching that and solving those problems. There's problems with storage, limitation of travel, I mean, and those type of things we'll discuss later, but I can't recommend, I won't convert my car, let's put it that way, as of today. We don't want to forget the tax aspects. There are incentives, there's federal and state tax incentives on certain things that you can do throughout this program. That in the next seminar, we might also tell you that not only the theory, but we're also going to bring in experts, quote unquote, on different products. That once we identify potential savings and we identify things that can be done later in the program, we'll bring in people who have products, current technology, state-of-the-art, latest thing, where they're at, gas-fired refrigeration equipment for HVAC, rooftops. Most of the facilities in the size communities we're talking about, you're going to have a lot of rooftops or a lot of what I call residential grade equipment. And then some of you will have central plant, Durant probably some central plant equipment, and Barnesville will definitely have some central plant equipment, I'm sure, somewhere. And some of the others may have some central plant, larger facilities. But we'll bring in a broad spectrum of different people, control systems, computerized systems. As a matter of fact, we need to make a note, this is a question we need to ask the people before we leave the seminar on that computer program for energy management. How many are interested in that? We've got a program, and I might as well go ahead and do it now, I guess. But we have a program, and it's probably premature, but tomorrow evening after we get through more information, if you're computerized and you have someone on board that uses computers, there's an energy management program that's available. It's a very good program. It tracks your utility bills once you program it in for a baseline, and then it'll actually track weather data. You have to just keep putting in the information, in terms of utility bills. It'll also write reports comparing back to your baseline data, and this year was a mild winter compared to the other year that's your baseline data. I mean, it's a very involved, but it's not that complex. It's just someone, if you're familiar with computers, can do it, or you can hand write it out. I mean, it's a little bit a lot faster if you're computerized to use a computer, and it'll do a lot more for you, like any computer will. But it's a really good program, and we'll discuss that in a little bit more in length tomorrow towards the end of the day, or maybe this evening at the reception a little bit. Unless, Ed, did you have something else you want to add? I was going to wait till after lunch to start the site and climate.
I would like to have open it up to questions and answers. We've breezed over a lot of the energy fundamentals, and I'd be willing to spend a little more time on any subject if someone would like.
I think I'll have questions tomorrow after I've read it.
Well, they're the basic elements, but hopefully what we want to put these in there for is when you go around and collect the data, you'll see, we're hoping these will ignite, spark from memory why, the people performing the audits they say, well, yeah, I can see how that works. There's terms in there that you don't have that I like to use. It's called thermal nosebleed. And I came up with that one years ago on, I was really a promoter coming out of college, naive and ready to tackle the world and solve the entire world's problems out of college. Subterranean housing was a big thing for me. And the more you got into it, the more complexity. And the more I got into it, the more I was convinced I wasn't going to build my house subterranean. There are a lot of pluses, there's a lot of negatives. But some of the things that come out was a term I use, thermal nosebleed, and you have it on every building. And for example, it'll be right here on this building. When you have, it can be any type of studs. Let's take a house, keep it simple. You've got a stud, we're looking at the plan, another stud framed in, and in between you have your insulation. Well, Then you have your outside material, whatever it is. Then you have your inside material. Well, everywhere there's a stud is a direct place for transmittance, thermal nosebleed. Just like having a nosebleed, it leaks. When you come to a corner, it gets worse. Uh-oh. Leaks out the corners. When you come to your windows, well, look at in a vertical application, you've got a 2x12 or what's called a header above the door, and there's usually 2 of them. You got top of your stud up here, down here, and then you'll have your wall below, and you have a window in here with, of course, its frame. So I don't have any other colors. Your window sitting right there. Well, typically then above, you start back your insulation, and then below, you have your insulation. But because of structural framing, usually there's no insulation, unless you make the people stuff.
That's right.
And none of them will do it, unless you're there standing over making them do it, guaranteed. Because we hire subcontractors to do insulation, and they go around with the poly seal, and they seal the seal plate, and they seal around your electrical conduit, and none of them will do this, and that's by far worse than other areas. And that's on residential. Well, you can explode the magnitude of that on commercial by far worse. And it's a bleed area, or a place that it can transmit heat and cold through, but there's no insulation. And it's everywhere.
Mike, why don't you quickly diagram thermal nosebleed at Enid City Hall, just as an example?
This would be a gross example. One of the things that we cannot believe as consultants that any architect and engineer could do in 1976 after the energy crisis to anyone. It's amazing. In the city of Enid, typically, if you have a wall like this wall, and here's your ceiling, and up here we'll say here's the structure, and you'll have a parapet up here, and your roof's up here with all your gravel and stuff on it. And this is the plenum space I've talked about earlier, where your ductwork and everything runs. Well, if you have one that has an overhang, a lot of times where this comes out, let's do an overhang like this. Well, in the city of Enid, they have an overhang where the structure actually comes out like this, and your walls here. Yeah, and then there's columns every so often to support this out here. But what they have, typically, this is conditioned space. Let's say this is 25 degrees. You want to keep this, say, 78 degrees. Well, this plenum up here is a return air plenum. So its temperature is going to be different, obviously, right? Well, the first thing you do fundamentally is you isolate all inside spaces from outside spaces. Well, can you see a problem with this design already? You've got 25-degree air hitting this surface here, hitting this surface, and hitting this surface, impacting this volume of air around the entire perimeter of the building, 2 stories high, mixing with your plenum return air. First thing he said, hey, guys, one of the things I want to solve is the maintenance building director or superintendent of maintenance for city. He said, you got to help me solve administration building. It's causing me unbearable problems. I can't control it. I'm getting bitched at all the time. I got 3 different I got city manager, 2 assistant city managers, and I said, they're on me all the time. I mean, I can't control the building. I can't control it. So we get after, we get to looking, and we open up at this point. We think, wait a minute, right there is you always put a wall. And you let this just be out here soft and unconditioned, but you separate this from that. Well, that doesn't exist. And then we go, golly. Because every time you open the doors here, it rattles the ceiling tiles. Because of the change in air pressure when you're coming through the vestibule, it'll just rattle the tiles. Well, when we come over here, there's a gap. This is a stucco soffit, and then there's brick and stone, and there's a gap, a literal crack of about a 1/2 inch. the entire building, 2 floors, entire perimeter. You got a 1/2-inch crack, and this building is about 26,000. That's bigger than that. It's bigger than that. I think it's like 40-something, 50,000 square feet. It's got a full basement, central plant equipment, no economizer cycle with a cooling load, generates, uses electricity year round to keep the building cold, and yet it's 25 degrees outside. And then the complexity of this, it's mixing 25-degree air and it's return air to try and get back to 78.
Like you said it a while ago, but I wanted to emphasize it again, that's return air plenum, which means that the plenum has to be negatively pressured in order to get it to return.
Right.
And that
And here you-
crack draws outside air, whatever it is, and it's a tremendous heat wall.
You're economizing.
That's right. That's our economizer cycle, but it doesn't work like they're supposed to. And then we find out that now this is where it gets beyond negligence to gross incompetence as far as I'm concerned. It's when the engineer on the project realizes it's such a severe problem in design, he puts unit heaters in the plenum to heat the pipes so they won't freeze. You've got a 5 kW unit heater spread throughout the entire plenum set on 80 watt?
It is about 82.
80 degrees to preheat the air so he won't bust pipes. He'll keep the
My
plenum
building's not
heated.
that old, is it?
76, 77. Designed by an architect and engineers.
It was one of the highest per square foot energy usage buildings in the whole city, and it was one of the newest, and we began to look at it to try and find out why, and found some of these things like that.
I mean, let's overlook the
After our
fact.
Review, Ed and I came to the conclusion it probably didn't have any engineers, it's all done by architects.
That's right. Well, I came to the conclusion it was obviously gross negligence on the engineer's fault. Whenever he saw that this bad, he should have said, "Hey guys, we need to change something." You know, you really want me to put unit heaters up there? For the record, if we got a problem with this, I'll have to state that I had to put unit heaters in your plenum because it's so bad at design. I mean, somebody was not communicating. I don't know who to blame, but it just you can't believe this actually happened. And this is not pre-energy crisis. This is post. And then the other thing, I mean, forget the fact that this wall surface here has no insulation in it. I mean, don't even look at those kind of issues. I mean, those happen everywhere. That happens. I mean, you've got a steel column, and then it's got marble panels around it. And you come off of the wall, and this column's 2 feet wide, and this wall, and this has insulation. But this doesn't. This happens every so many feet, so it just transmits code, I mean, in a 2 foot wide area. So, I mean, overlooking all those things, overlooking that you've got stone walls in other areas and brick that have no insulation whatsoever. They're just double brick inside now. Looks real nice, looks real pretty, real low maintenance, terrible in energy. Overlooking the fact they have large skylights. You know, anytime you have this creates control problems, and I mean, in good buildings, this creates control problems. It takes a good engineer whenever you've got a building, and here's your roof, I'll draw an abstract here, and your parapet, second floor, little walls here, and then you got your bottom floor, and your ground, and say here's your glass or whatever you've got. Well, whenever you come into an engineer, and it's easy, it's like your house. You've got an upstairs zone, a downstairs zone. Okay, then you solve the problems within their zones and the loads, and well, this one's got computers on it. No, this one's got the entry where all the people are coming in and out. And you solve those problems. But then you come in the middle of them and go, you know, gosh, I like these. Architects always like these. Let's just put a light well where people can spit on each other. Excuse me. You know, let's put a light well. This will look real neat. You know, I don't know why we do this, but everyone likes them, you know, and you can look down on each other and it's real cute. Okay, well, hey, if we're going to do that, let's put skylights. I mean, you want natural light in here, so let's put some big pyramid skylights. Well, you just created some real complexities for your HVAC man. You can solve them, but you've got to deal with them. Now, you take this of the city of Enid and couple that with what I've just shown you, with your cold air coming in from everywhere, and your solar gains and your controls and your drift. I don't know how they could control anything in that building. And no wonder the man was just going nuts. And no wonder the frustration. Well, you had the frustration of the city managers cannot believe, they can't accept, he's not doing his job right. I mean, that's what you get into issues. And he's an internal employee telling him, say, hey, there's something wrong with this building. We need to spend some money. There's nothing wrong with this building. We just built this building in '76. I've had people look at it. There's nothing wrong with this building. And he said, well, hey, he told me, he said, guys, without a new control system, I cannot. He has to run the boiler and the air conditioner simultaneous, full blow. He's satisfying heating the basement with the boiler running 100%. He can't even idle it down. He's having to run the HVAC 100%. You know, it's incredible. And they said, well, why is the utility bill so high? I can't
They even
understand.
tried to take over the utility works, the electrical, didn't they have a vote on that?
No, not me.
Must've been pretty bad.
It was, they did on gas. They did on the gas and CV. But, so that's just been a nutshell of some of the things that you uncover.
Talk about a nosebleed. In our library down here, we got a recessed light, a big skylight, and it's massive. And I've been working for the city grant for 3 years. The first day I come to work, we had a massive rainstorm. So the librarian said, Pete, would you come over and take a look? Now she's got garbage cans, 32-gallon garbage cans all over. And we're just finding the roofer. We cannot get the leg shop, and so we're just going to court right now to get a new roof. But it's a recessed skylight. The architects that I talked to said, you want problems with that recessed skylight. But I'm talking about the skylight's 4 feet below the main roof. And I mean, talk about a swim.
I guess so. I haven't seen that one yet. I thought I would encourage
I'll take some pictures of it and I'll make a point to send it to you. It's unbelievable that somebody would design something.
Well, it's a situation, who gets abused the most in the industry are municipalities, schools, and churches. Historically are abused the most. You know why? It's committee.
Yeah.
There's no one that has total authority that runs it. And you've got city councilors elected for a certain period of time, you get the turnover city managers, and et cetera. And the same with the school board, same with the church board, and they all accept the professionals. Same happens in medicine. I mean, that's why you have malpractice suits. But that's why it's important. Once you understand the way your buildings operate, you understand going through this program, the next time that a designer comes to you and says, hey, well, this is a great idea. Wait a minute, you know, and that's what you need to be doing more. We better go lunch.
Are some of you going to drive? Or is everyone going to walk? I think it's great.
Mr. He went with the,
With Mike? Mike Neville? Name where Mike Neville was.
Mike Neville was just
A little bit late. Had one comment on the way back in. We're talking about controls and thermostats, et cetera. I noticed that on the thermostat outside here, the set point 65, the temperature 75. It's not a classic case of what you want on your controls. You want to be a little bit more accurate than that. It sense temperature a little bit better than that. But one question was, what do I think about dummy thermostats? Have we ever used those or find those, you know, some people? And it's true. People love to have a sense of control. Everyone wants to be in control of your own life. And the more of a manager you are, the more you want to manage your life, manage this. And no one wants to be told that, especially city managers, assistant city managers, they can't control. That's why it ends up in supervisors and managers' offices, you know. But a client I was with, and it does work. There is something about it. If you can go over there and turn that down if you're hot and it's cooler, you think you've solved the problem, whether you really did or not. It may not do anything, but in your mind it did.
we set a dummy thermostat in our conference room in the library over a year ago. Even the city manager don't know.
Well, that's what
And they just worked that one, just coming and going.
But
That's
I
right.
do periodically have people complain, well, I turned it down and nothing happened, at which point I have to call him and he has to pretend
Yeah, get around
to-
there. And, well, just give us some time. Just give us some time.
Yeah.
Well, they had the same thing at Telex, and one of the person at that time in charge of the maintenance department had just a few assembly line in the manufacturing people. They had a few people in one area that constantly complained about being cold, and it didn't matter you know, what, summer or winter, she was cold or she was hot. And there's like 3 people like this out of 60-some people. And he would go over there and she'd complain to her supervisor, and then the supervisor complained to the manager. And I mean, product manufacturing is where you make your money. So you keep those people happy, you know, they give them a such, hey, I'm paying your salary, I'm making the money for this company, by God, I want the problem solved because you know, that's the one bringing the money. You're a necessary evil. You're here to keep us happy to make money. So he would go over and look, and he'd get a thermometer out. It's the same as everywhere else. What she is sensing, her workstation is near a diffuser. And if you've ever been in a restaurant, to satisfy the room, and especially if you're near a sun space, you know, or glazing, you're going to get a cold draft over you because it's satisfying the whole volume of room. Well, in a restaurant, you say, hey, can I move this? You can get up and move. Well, in your workspace, you know, that's where she works. And she's in the process. And no, I'm sorry, that's not acceptable. You know, that's not the problem. Well, that's what the problem was. And she was getting a draft. There's nothing he could do about it. So what he did is he just got a thermometer, and he said, well, I'll tell you what, from now on, at your workstation, I will keep the temperature with the supervisor. What temperature do you want it? You be comfortable at? So she picked the temperature, I don't know, 74 degrees, 76 degrees year round, be ideal for her. So he got one of these just cheap, large thermometers, and her workstation's here, and on the wall right over here, he just broke it, set it, fixed it on 76 degrees, hung on the wall, and complaints went away.
Well, I just hate to go to the store with my wife when she has to send me to Homeland. I go in there in July, and I better take a sweater with me when I leave the house, because that's the coldest place I've ever been. I don't like shopping there, I really don't.
Well, it's amazing, the difference in temperatures and people. But that's interesting to tell that story, because it works. I mean,
Just gonna have a delayed thing on her, so when he turns it down in about 15 minutes, that other hand automatically starts swinging down a little bit or up, whatever.
that's right, so it moves. Okay, well, this next section I'm going to discuss is site and climate considerations. As everything so far today that we've discussed, you might ask, well, why are we discussing these? Because these are kind of after the fact. This is great if we knew all this before we built our buildings. And that's why this one, site and climate considerations, kind of late, you know, but not really, because you're going to build new facilities, you're going to add on, you're going to reconfigure, and not only that, but you can apply every one of these items to retrofit and to impact your existing buildings. If you know how to deal with the local environment, you can impact them through trees, plantings, and other things that will help save energy. Even though the building's been there 10 years, it's amazing what a tree will do. So with that in mind, I'm going to go right into the introduction. Again, for the essence of time, I'm not going to read all this, but when you look at it, every region of the country has its own specifics. You know, America versus Russia versus Africa versus South America, Antarctica. Okay, and then from there you go into Oklahoma versus Colorado versus Texas versus. And Oklahoma is some of the things that we look at, and that's what's considered your regional area. That would be on the next page. On your regional area, such as Oklahoma or state area, first let's look at the regional area. We're considered in the southeastern part of the state in terms of with Florida and the others. And it has its own certain latitude around the earth, longitude, degree days. If you strike a line from Tulsa and follow it across horizontally, it's amazing how close the similarities are in degree days. We talked on earlier. Well, from there, let's look at the state. The things that are important to us, where do our winter storms come from? Northwest to southeast predominantly. Not always. We have swifts and swings that will make them push in different areas. Springtime or prevailing winds are from the southwest, go to the northeast in terms of storms and constant breezes. One thing that's surprising on that program at Edstone I mentioned earlier we worked on, according to Los Alamos Testing Laboratories, Oklahoma has the most constant wind speeds in the nation. Not the highest, not the lowest, not the biggest gust prevailing winds, but the most constant wind speeds. And at that time we were looking at wind as a possible application, and it still can apply. Wind energy to generate electrical power, Oklahoma is one of the best suited areas for it, according to all the research data Los Alamos has performed. Also, as I mentioned earlier, it's unique to Oklahoma and other parts, but not so much as compared to Maine and other cities. we have those quick shifts, quick changes, quick deltas. I mean, Albuquerque has them too. Again, if you follow the line across, it's amazing. You know, the parallels, Albuquerque's a little bit lower, but the one thing that's unique to our area is the quick temperature deltas. We don't have long periods of constant temperatures, except usually it seems like August. It's unbearable. Somehow we've somehow got August to deal with, but other parts of the year, you know, if you don't like the weather, like Will Rogers, whoever made the cliche, wait till tomorrow. And so that's another characteristic of quick load. So your equipment needs to respond in a quick load. Like I was giving an example of a wood stove versus a large masonry fireplace. A wood stove immediately starts giving off the heat and addressing the demand the moment you get it cooked up versus a large masonry fireplace. So that's the kind of stuff you want to look at, and everyone, this is common sense, we all know because we live here, but then again, somehow we tend to forget because we let technology address all this and solve the problems. Well, the same is going to be true with the city. A city in different areas of the state has its own particulars. Enid, for example, versus Tulsa. Enid does not have near the water. In fact, they don't even have lakes. They have a water well, it's an aquifer. They get all their municipal water from underground wells. Well, Tulsa gets theirs from lakes. I mean, green country, we have lakes all over. Well, Charlie mentioned on humidity. It doesn't impact the humidity levels. Another thing will happen out there, their fronts will come in Enid faster than they will in Tulsa area because it's flat and it drops out of Colorado, those quick shifts, and they're right there when it drops it. I mean, they can have you can literally see it. I goose hunt, haven't been for about 3 or 4 years, but west of them, called Jet, Oklahoma, you can literally see a 50-degree front coming at you. If you've never been, it's kind of a unique experience. If you're sitting out there and it's, say, 40 degrees, 45 degrees, and you're pretty comfortable, and all of a sudden you see this major front, you're going, oh man, looks like a storm coming. Within 30 minutes to an hour, it's blistering cold, and you can literally see it coming towards you. And so each part of even the cities have their own. And then within the city itself, to get more specific, downtown environment is a lot harder than a rural environment. Because back to mass, we talked about mass and the impact it has. Okay, take all the masses of all the buildings, all the concrete, all the paving, all the streets, and it cooks all day long, and then it releases at night as the temperatures come down. It's starting to release back into the atmosphere, so the temperatures of the downtown areas are hotter than they are out in the rural areas. And we have a tendency to keep covering up. I wanted to do a climatology study after college one time, if I ever went for my master's, on the impact in the nation and how we've changed our weather from now on, historically. And I'm convinced that if someone would track what we were in terms of the cycles and what our temperatures are, they're talking about global warming, this is what I was talking about. You've changed the winds, you've changed the climate, you've changed humidity levels, you've changed the environment. You just think about all the massive earth moving across the United States, of all the earth that we've moved in development. And just take Houston to New York City, just pick out one city, Los Angeles. It's incredible the impact that you can do to a locale in a micro level. And so, you need to think in terms of that and look at your own environment. And then the specific site comes into mind. Do you have deciduous trees? Do you have evergreen trees? Do you have no trees at all? Is it a paved area all the way around the parking lot? Is there grass around? Is it hilly? Are you next to a major traffic or expressway? Because then you've got not only noise pollution, but you've got environmental pollution in terms of fumes. You've got the heat given off by the gases of the cars. They'll heat it up as well as the mass. So you've got all these considerations when you look at every building in its particular site. I mean, is it exposed to the east, west, north, south? And they're important because for some reason we think in classic architecture, man has always dominated, in theory, the environment. It doesn't work that way, but we have a tendency to ignore environmental issues and design classic architecture as far back as the Roman days. I mean, there's certain elements of nature that we took into account, like water, rain, snow, but I don't know why we have to think all the buildings, all the elevations look the same. You get a glass tower. If you've seen one side, you've seen it all, except you're looking for the entry. Take your classic buildings, your Doric column, the Parthenon, and all that. I mean, they're all, why does all the elevations look the same? why have we got in our mind that we need to keep everything perfectly symmetrical? It's browbeat into our heads in design in terms of symmetry and all this, but you ignore the glass exposure on the east should not be the same as the west or the north or the south. And the same is true with your mass. The same is true with where you put the rooms inside the building. So what you do with a building impacts the way it's going to use energy, both what is around it and how you design with respect to what's around you. Or pretty well talked on the site analysis on page 54. When you look at this, some of the two biggest impacts that can affect you are solar radiation and wind. Wind can impact infiltration, which we'll talk about later, and solar radiation has to deal with the external load of the heat being applied to the building when the sun's out, winter versus summer. You need to plan for, obviously, the 2 seasons in Oklahoma. Knowing what you know about the climate, knowing what you know about the specifics, then you want to design for heating, you want to design for cooling, winter versus summer. And obviously you want to optimize winter for heating and optimize summer cooling. Well, if you allow engineers and architects, they'll approach it from a purely analytical, isolated, technological. The architect looks from an ego standpoint, unfortunately. I mean, he's designing something unique and different and neat and art. It's an art form, as well as functional, as well as aesthetically pleasing, as well as different because he wants everyone to say, hey, that's mine. You know, every one of them have their own trademark. The engineer wants to be the best engineered, masterpiece controlled, people comfortable, et cetera, et cetera, et cetera. With no respect for a person, site, or locale usually, because a lot of times they only live in that location. You know, in a municipality, they could bid your work and you could be the low bidder. You don't have to bid professional fees. You don't really bid them, but you know, you take RFPs, requests for proposals, and sometimes economics dictate. Well, for example, in the case of City of Enid, I think it's a proven case in point that's not necessarily the best approach for them. I don't know if they took RFPs, picked the lowest, but surely there's got to be some justification for that. I mean, hopefully, in their instance, they didn't pay the highest or the quote-unquote most qualified. Or someone needs to look at the selection committee. But in looking at you, the people who are there need to look at, the people who are going to use it need to think about this, because consultants do it and you're totally vulnerable to the quality and the understanding and the sensitivity of the person that's doing that design. But if you on your side of the table bring questions to the consultant and issues to the consultant and have him address these issues, then you can end up with a better product. On the heating and cooling cycle, obviously one thing to look at is in the wintertime, on page 55, you get plenty of sunshine. In the wintertime, you can't get too much sunshine unless you have a large cooling load in the wintertime, which your large facilities can have, but they're usually interior zones. As a general rule, your perimeter zones need heating. Not always, but on an administration building, most municipal buildings, unless you have a large internal process equipment that produces more heat than you're losing. You know, as a general like this building, even on the perimeter, you'll need some heat typically. When it's safe. And on the interior zones, you can get into cooling like a computer room or a blueprint, a printing office. The interior zones can sometimes be year-round cooling, or just the nature and the size of the building can dictate that. But as a general rule, plenty of sunshine is okay in the wintertime. But does it offer protection from the winds? You can't really always protect from the winds, but with trees and landscape, they're cheap. I mean, they really are cheap. And you say, well, yeah, but it takes so many years. Well, how long do you plan for the building to be there? I've always had people tell me that, well, paint, it's just like paint on the surface. Everyone wants everything built right and high quality, and they cut back as the closer you get finished on the job, the more they tend to cut back. Finishes are cut back on because, well, you can always add them. Landscaping's cut back on because you can always add them. but somehow it never gets added. And the excuse on a tree is, well, yeah, it takes 10, 15 years. Well, yeah, but hopefully the building's gonna be there 10 or 15 years. I think it ought to be there 50 years, 25 years. Buildings have a life cycle too. And we design a building, it should be life cycle looked at from a standpoint of City Hall. It's a throwaway building. You're gonna build it for 25 years, pass a bond issue for $2.5 million and throw it away in 25 years? I doubt it. You're just paying it off. So it has a life cycle. How long do you want that facility to be around? And you start thinking those terms, you go, God, if it's gonna be around 50 years, do I want rooftops, cheapest cost, steel frame, wood fascias, high maintenance, incandescent lights? Sounds pretty dumb. I mean, if you really look at life cycle and why you're using the facilities, you want the best you can possibly look at. Well, the same approach goes with the site analysis. I mean, it's gonna sit there. You're not gonna pick up and move it. It's not a mobile home. One gentleman, I think it's Pete. Yeah, Pete mentioned the fact on a house he bought and the utility bills he had on that. And through some investigation, he found two things. He found a real bad situation where the builder didn't insulate like he told him he did. Another situation, he planted some trees and cut the sun load down in the summertime when it's cooling. Well, just the reverse. I said plenty of sun in the winter is pretty good. When in the summertime, you don't want any. Typical. You know, I mean, the less you have, the better off you are. So there's trees you can use evergreens on the northwest corner to block those prevailing winds and a landscape issue. And you can create nice little alcoves. I mean, it's just a matter of creating. Everyone's got park improvements. Everyone's got human spaces that you need on every street corner. I mean, on municipal property, you've got employees, you've got people walking by. What I'm talking about, there's never enough people spaces. You know, you've got your typical street intersection, and let's say this is City Hall, and let's say this is north. You've got sidewalks. Depends on what the location. Again, you can use nice evergreens as a cluster in certain areas, but you can also create a little alcove with a seating group there. You know, for employees or for people walking by, or it depends on how you're using the building. I mean, there's all types of potentials to use the landscape, make it functional, but also make it where people appreciate it, like a park environment. Because I don't know anyone that doesn't appreciate nature. I mean, a beautiful plant, a beautiful azalea, but the other cycle is maintenance. You know, you've got to couple that with common sense and what your soil types are. I mean, there's a lot of things to look at, but it can really impact and save you energy. You can plant trees around all your facilities, shrubs. They say that, well, another thing we have a tendency to do here is we like to have a golf course look environment. Well, that's one of the worst things you can do. If you'll let your grass grow taller in the summertime, it'll actually drop the surface temperature of the earth. You know, you don't want to let it become waist high and wade through, obviously, but it also helps the grass stay healthier. It keeps the blades cooler, you know, within a certain, they recommend in Oklahoma in July and August, let it grow at 3 to 4 inches or something like that, instead of keeping its scalp down to 2. Now, the different turf people can tell you that. But that right there helps drop the surface temperature. Your shrubs will help protect your foundations and help deal with the temperatures there. It can also block, depends on the type of shrub, it's evergreen, infiltration beating against winds, beating against the building. So when you look at that, all those issues in just terms of landscape, there's a lot to look at, but also there's a lot to look at in terms of the site itself, in terms of how you orient the building. Just some quick basic principles on, if you've got a building, and somehow they're never always square unless you force everything to make it that way. They're typically rectangular or even a little bit longer, or they usually have an odd hickey somewhere. The most efficient thing, depending on what you do, is obviously we know that the southern exposure is your best year-round exposure that you can deal with. In terms of, you can collect heat off the south and block it by overhangs in the summer and keep the sun off of it, off your glazing. And that's your collection area on the south side if you want to heat up a lot of glass. Your north is your best for lighting for eyes in the wintertime, visually, in terms of natural light, the least amount of glare. And it's pretty good in the summer, except the evening and early morning. but it's also the worst in the winters for the storms and the infiltration and the cold draft that gets next to glass, because what happens is convection. You sit next to glass and the temperature comes through and it'll cause a loop right there at the glass, because the hot air will come over from the diffusers, will drift over against the wall, drop down the glass, and will return back, because that's a cold surface and it'll push it back. And so it'll cause a drift or a draft right there at that. And that's why they have diffusers usually, like if you look out here, they're right at the bottom of the wall, right at the glass. That's why in your house, they typically put the diffuser right below the window in your rooms or above, to hit that at that source where you're starting that draft in the room, which makes the perception of comfort. Well, the way you orient the building and set it on the site can have a major impact. This house with north being up versus the same building with north being up is drastically in difference. And in just rudimentary terms, I can't give you a percentage of savings off the top of my head, but it is profound in the fact that longitudinally, your cooling load, your west is going to take your largest beating in terms of surface temperature. It'll start on your south and go around and really impact your west. I mean, because from the west, from about 2:30, 3 o'clock, it's in this position to the solstice, June 21st, as late as 9:30, the sun will still be up, just about to set. And it really beats this part of the building really hard and back from there to there. Well, if you take the square footage of that area being impacted versus the square footage of this area being impacted in terms of summer load and cooling impact, you more than double your surface area exposed to that western sun just being beat on it, which again affects the interior and how much energy you consume. So the way you set the site can impact your building. You want your east and west, your smaller exposure. You want your north and south, your longer exposures. Your buildings become more efficient that way. It's just the nature of the way it works. And the optimum location is off polar or magnetic north and south is stay within, and that's in there, stay within about 15 degrees of true, set this plane within 15 degrees of the true east-west or off the north-south axis in terms of the orientation, overall generalities. I mean, we're talking very general terms here, because a commercial building is less sensitive than a house to these issues. A house is much more sensitive to site location, site specifics. It's impacted a lot faster. And the reason for that, proportionally, you have a lot more surface area per square footage of heated space on a residence versus commercial. You have much more square footage of heated space to ratio of exposed exterior. So commercial buildings and industrial buildings are not nearly as sensitive to thermal exterior loads. I mean, they are sensitive and it does impact it, but not near as much. The smaller the frame, like a house, is much more sensitive to those issues. The winds and the way you set that we've talked on, but they can drastically impact. For example, I don't know why in Oklahoma we have, except for allergies for myself, there's 4 to 5 months out of the year that we can open the buildings up. And there's nothing that smells nicer than a fresh spring morning, sunrise, 8:30, walking outside, just like today. It's almost this temperature. You just go, man, this is just, you can just smell it. It just smells great. Why don't we open our buildings? Why are commercial buildings fixed? Why are they static? I don't have a good answer, except monkey see, monkey do. I mean, Ed, from an engineering standpoint,
Well, I think it's cost. It costs us more, a little bit more to do a better job. A lot of times we're not allowed to do that. I think that's changing too. Building designers are becoming more sensitive to the need for free cooling, getting outside air into the building.
right? Because it's a golden opportunity, but it's all fixed glass. I mean, I don't know why you couldn't open a building up. They used to pre-World War II and then after World War II. But then when it really started in the 50s, we just started going berserk. we kind of lost touch with the reality, honestly. The massive, one of the largest booms historically in our nation's history, everything was so economically cheap, and we were on such a power curve after the war. And hey, anything was obtainable. The world was at our fingertips. And we lost sight of just common sense in many, many ways, because you didn't have to. You punch a button, flip a switch, hit the foot pedal, we're off. And that's mentality still here. And you can do that, but you pay an extreme price in today's market. And I think Ed's right. I think we are going to see more and more sensitivities, more and more, I hate to use the word environmental design, but basically that's what it is. Used to, they come up with a buzzword every time. I call it common sense. I mean, all your farmers knew that where you locate the farmhouses off the floodplain. Well, what are we doing? We're building floodplains all over the place. The farmer knew that it was hot, and so he puts porches all the way around his house, and he has a way to open the windows on the second story, and he has some fans, and it cools as it hits the porch, goes to the downstairs, and goes up and out. Probably some of you grew up as kids, slept outside in the summertime. It got so hot, you didn't have air conditioning. I mean, you could be hot, sleep inside and sweat, or you can go outside and sleep on the lawn. That's what they used to do. Well, and we've got away from all that. And I'm not saying I want to go back to that, but I'm just saying there's a happy medium of common sense. To me, it's common sense. They called it passive solar back when the solar was a big push, and called it passive versus active. Passive means, it'll work for itself. Active means it's some kind of mechanical system, and it's engineered. Well, now the next thing is going to be environmental, because you're real sensitive to Mother Earth and environmental issues. It's common sense to me. If you want to be comfortable, you want to enjoy life, quality of life, and our emphasis on this program is to save energy and to manage it properly, because the resources they're not renewable. I mean, some are, but the majority of them, they're getting farther and farther. We're using up everything we own. From a site, summer cooling versus winter cooling, or winter heating, on the sun's positioning, I'm kind of on page, I'm not really following this that close, but on page 59 it starts on it.
It would be kind of hard to get a perfect situation there, wouldn't it? From summer cooling to winter heating with your trees and stuff?
Not really. It just every side's different.
What'll work for the summer sometimes work against it for the winter, wouldn't it?
Yes and no. Deciduous trees on the south that shed their leaves in the winter expose you.
Okay, I see. Okay.
And evergreens on the north,
I understand.
which will block. And also evergreens are real good for sound. Evergreens are real good for noise pollution in terms of traffic. They can help block that. So there's more than just energy. I mean, they have a lot of pluses to them. Looking at the side, not only horizontally, we looked at if the house was setting here in the sun's position in the wintertime versus the sun's position in the summertime, going all the way around. The same's true in the wintertime. I believe 37 degrees, if I still remember correctly, is the highest angle in the winter. And that's December 31st, the winter solstice. Okay? In the summertime, ooh, I like that. I think it's like 97 or 110, or it's up there pretty high. It's between 90 and 110. I don't remember off the top of my head what it is. So you can obviously see with an overhang the difference in the time of day that it'll have on this glass. If this wall is all glass, as you can see in the wintertime, for example, if you've got glass up here, you're wasting your time. The glass up here, well, in a house or in a commercial building, the heat's going to migrate up, it's going to travel out. It's a high source. That's right here, because this is all insulated. I'm using just houses, for example, because they're easy to draw in simple terms. So, and that's not doing anything to gain heat in the wintertime. It's not doing anything for you. From this point down, it's working for you. Now, as the later parts of the day, it'll start to hit in, but you're starting to lose your temperatures. Well, conversely to that, or opposite of that, is your overhang is working for you in the summertime. So these are some of the design issues that you deal with that we can touch on later on commercial buildings, you know, if you want a lot of collection area, you ought to have it on the south side. It ought to be designed to where it's not just an aesthetic thing. Architects approach it from an aesthetic value. They want to balance where the glass is, mask the glass, nice little elements on the outside, totally ignoring these issues. They're looking at it from an aesthetic standpoint, an artistic standpoint. But there's much more to it. Basically, you want the most sun in the winter and the least in the summer. And with a commercial building, you're better off to balance that with landscaping versus just sun, no sun, because you deal with internal heat gains, which can require cooling in the interior zones year round. So you don't necessarily always want a lot of exposure on the south, always on the commercial. Depends on the size and scale of the structure. People considerations, this goes back to, we've already touched on it, and I don't want to browbeat that, but the same is true with common sense. We used to wear sweaters in the wintertime to be comfortable. We'd wear heavier clothing, wool clothing, etc. Again, technology's taking us away from that. We can wear polyesters. Women wear silks in the winter. Hey, they're sexy. I like the way they look, but they don't really make sense. You know, wear a silk dress in the dead of winter because there's just not a lot of fabric there versus wools. Same as in summer. I've talked on that. You know, why this is perceived as what you should wear as attire. I mean, I don't know why these things were ever invented. Other than the fact that after you're finished the meal, there's absolutely no functional value whatsoever. But yet we let things like this dictate our life. And it dictates decisions to us. Well, this same type of mentality is in the way we function our buildings, to design our buildings. Why? Well, that's just what it's done. So, you know, I would encourage, you know, for people to have people considerations and have it. It can be fun to, you know, create ways to people can dress and still be professional in the summer versus the winter time. You know, I mean, it's simple. You know, have a contest for the weirdest sweater. You know, something like that. And get people used to wearing sweaters, and someone will show up with some obnoxious looking thing and they get a cake or something. I don't know. In the summertime, it's who's got the loudest Hawaiian shirt. You know, and a short sleeve shirt, you know, whatever the case might be. But you can do things that creates, and your human, instead of your, what they used to call them, and now they're called human resource people, will tell you, but well, you need to do that, and gets the workplace and gets people fired up and gets camaraderie and all this kind of stuff. Well, it's true, it does, and it gets people excited about it. It makes work fun instead of a job. But also, you can use that to your advantage to actually save energy. I know it's kind of trite. On the next section in there is this page 64 through 68. It talks more about the deciduous trees, the roles they can play, and also the sun, the position of the sun. You can obtain these sun charts. They're for every latitude and azimuth, you know, depends on what degree of latitude that you are, and it'll actually tell you position. In fact, if you'll turn to page 65, the adjoining page is the figure I'm talking about. On that particular chart, I'll turn it around so people can see. So I wish I'd brought it. This is the highest position, December 21st, which is the winter solstice. It's right at 30 degrees. Temperature and the time is high noon. And you can see in high noon in June, which is the summer solstice, look at the sun's position, how much higher it is. And they've got them plotted for you for every hour on the hour, the position where the sun's at. So these are readily obtainable. You'd think the architects and engineers would use these when they're done. But it's a very, very much an eye-opener. The same is true. We put another chart under energy fundamentals. There's one there we don't have to turn back to. It's called the mean number of hours of sunshine. And I've got Oklahoma City and Tulsa marked, and it shows you for each month and for the year the average hours of sunshine per 24-hour period per month, which is interesting. You can use that not only for designing the building or for consideration, but also from like on street lighting. when you're calculating the actual hours of operation, and that's another subject we'll talk on later, but that's one that'll make you wake up and take notice when you see what you're charged for street lighting compared to what you're paying for the actual electricity used in the street light. It's a tremendous program for utility companies. It is a money maker. I mean, it is a gold mine for them, for street lights. It's a good it's not good for cities. It's not good for, unless you own your own system, then it's a different issue. Ed or Charlie, can you think of anything else on the site that you might want to mention, or? Because when you go out there and look at your buildings, and you read these and read about the impact, then go look at your own building and look at the fact that there is no evergreens, there is no deciduous trees, you're not blocking and sitting out in the open, just cooking like a, well, I use example, like a beer can. You know, you set a beer can out there, it's aluminum, it heats up real quick in the sun. Well, the same's true with mobile homes. Because mobile home has a lot of surface area to a small square footage, and therefore the exterior thermal loads heats them a lot faster both summer. They get them colder faster in the winter and heat them faster in the summer. Well, your building's laying there just like a cooler's can. It's sitting there either baking or freezing, you know, and it's amazing when you go to the site and look at which side your glass is on. They put the side of the glass on whichever way the street frontage was. You know, you've got corner deals, well, they want it facing this way because that's the way it's always faced. And you stop and think about, well, why did we do what we did? It had nothing to do with energy, nothing whatsoever. None of those values were even considered 9 times out of 10. It was just done. But there's things you can do to address it. I mean, even if you have a street that in an urban setting and City Hall is right against the curb, you can still plant some trees. I mean, you still cut a hole in the asphalt. You can get some certain trees to get a certain scale. You know, you can do different things to them. In some cases you can, you know, but at least you'll know next time what you can do or what you should consider doing. Did you all have anything yet?
I was just thinking about buildings that appear to be all glass on the outside, and the cities may have some of those. Frequently they are insulated glass so that it's not really vision glass, and you do have to distinguish between the insulated glass and the vision glass. It's handled differently in the load calculation, where it might appear to be a full 10-foot high glass wall that's really only maybe a 5-foot section of glass
Right.
with insulated. You can show how that might appear.
Well, that's a situation where it's true, but that insulated glass would not be near as well as if it was brick or had mass to it. Typically, a lot of times you'll have what's called a mullion, or the top aluminum piece that's at the top, and let's say this is your roof structure here. Your ceiling's there and your roof structure and everything's up here. You've got glass that sets insulated glass, and you have another mullion or a member, and then another piece of glass that goes on down, and your bottom one, and here's the floor. And what Ed's talking about is a lot of times this will be non-vision glass, you can't see through it, but it looks real close to this color of glass, and they insulate on the back side. And then this will be drywall, or vinyl floor, or wall, or whatever the case might be. This will be finished off below. And then you'll see out here, and this is typically about 3 foot high, 2'6", 3'6". And that's called spandrel, or non-vision glass. And obviously this would be a lot better. If you're going to do that, you'd be better off to put brick or something down here to slow down that thermal change. But that's what he's talking about. You have to distinguish between this and this in the audit. It's real easy to tell. Well, Charlie, that's about right. It's about time for you to come on.